I'm Isabel Tai, this week's project manager of the group number 6, the Six Sigmas, along with members Daniel Leach, Jasmine Alexander, Wesley Bennett, Ghost Sheikh, Muhammad Farhan Muhyiddin. For background info of this project, the Organization of Texas Parks and Wildlife are looking for an optimal vessel that would work in various conditions to perform marine operations. An RPF would require to take a multitude of parameters and factors into consideration. These various parameters and factors result in a total of 24 different vessel configurations, in which physical configuration factors include size, either 34 feet, 36 feet, or 38 feet long boat, hull material made out of aluminum or fiberglass, cabin design of half a cabin or either a 3/4 cabin for workspace, and an engine that is composed of a single diesel or a twin double diesel. Along with these configuration factors, we also have evaluation factors that include construction, operating costs, operating conditions, and safety. As a group, we altered the original selection factors to what we saw best appropriate for the category. And that said, under operating conditions, we have considered workspace, sustainability of speeds of 20 to 22 knots, and 30 to 110 degrees Fahrenheit. Under our new category, safety, we take 15% reserve for rough conditions, 30-knot winds, and 5-foot seas into consideration. And on the right, you can see how we distributed the constraint minimums for each factor and how we distributed the weight for each subfactor, like labor, material, and durability for things like construction. We assigned a total weight for each construction, operating cost, operating conditions, and safety. For the construction factor, we considered each labor, material, and durability for each physical configuration. A larger boat would require more work and more labor to produce. And similarly, more materials are required for a bigger boat, so each increase linearly. In regards to durability, a larger boat would increase mass and therefore increase durability. And although aluminum is more expensive, it is easier to work with, making it more cost-friendly in regards to labor costs in comparison to fiberglass. That said, even though fiberglass is cheaper, it is much more harder to work with, especially regarding boats, which makes labor costs more expensive. And regarding durability, assuming salt corrosion is not too much of a big issue, this would make aluminum the most optimal choice as it is more durable than fiberglass. There is more work to be done regarding installing a second engine, but although this is true, it does not differ too much in comparison with installing a single engine. Regards to material, a second engine mount adds to cost, and a second engine adds redundancy in regards to durability. For cabin design, there is a significant impact on labor cost. It adds design complexity, materials, weight, safety, precautions, and wind resistance. And reduction of cabin size reduce required systems of integration like electrical, ventilation, and plumbing systems. In regards to material for cabin design, additional material is required for cabin structure and interior. Or if it was half a cabin, it would require less, and 3/4 of an engine would require more. Similar to size, an increase in mass would therefore increase durability. For operating costs, a bigger boat would definitely equate to more fuel being used, as well as more maintenance to be done on the boat, therefore bigger cost for the work that has to be done. Fuel costs are not directly affected by the hull material, but regarding maintenance, aluminum is, as stated, less costly to maintain, thus being more manageable to maintain. And by default, twin diesels require more maintenance and money. Lastly, although the size of the cabin does not directly affect fuel costs, it would require more maintenance as there is more workspace. For the operating conditions factor, regarding size, a larger workspace would require a bigger boat. But having a smaller workspace would mean less water resistance, and it would not be able to sustain up to 20 to 22 knots of speed. And in the case of temperature, the size of the boat would not directly be affected by it. For hull material, aluminum allows for larger open areas on the boat, whereas fiberglass have molded designs that would limit the alterations. Because aluminum does have a higher density than fiberglass, it would have more issues with maintaining boat speed. So it would have more issues maintaining the speeds up to 20 to 22 knots. Both fiberglass and aluminum are both unaffected by temperatures and therefore are able to maintain the temperatures of 30 to 110 Fahrenheit. And by default, twin diesels do take up more workspace, but both twin and single diesels can achieve max speeds up to 22 knots. And again, engine is not affected by temperatures. Lastly, a larger cabin would equate to a smaller workspace. Half a deck would equate to more desk space and less weight, but because it allows for more desk space, it would make less insulation. For the physical configuration factors considering safety, a bigger boat would accommodate 15% reserve for rough conditions, 30-knot winds, and 5-foot seas, as it would allow more stability and precaution in adverse weather. To have a 15% reserve for rough conditions, the hull material should be robust enough to withstand additional stress, and this being considered, fiberglass and aluminum both have advantages in terms of strength and weight, but the material should have also structural integrity under the influence, such as winds and seas. When accounting for rough conditions, a twin diesel provides for more reliability and thus more power. And when taking cabin design in consideration, it should ultimately minimize the impact of these harsh conditions on our passengers and provide secure storage and robust fixtures. As you can see here, we have part of our Excel sheet that we made with each of the 24 possible configurations. We gave each subfactor the rating of 1 to 10, multiplied that rating by the weights collectively decided upon, and then we added each to gain a total rating for the factors of construction, operating cost, operating conditions, and safety. And you can see those in the pale yellow for each of the ratings and the total weights. In our Excel spreadsheet, we were able to rank each possible configuration from 1 to 24, 1 being the best with the highest score and 24 being the worst. And as I go through this, you can see we listed each of the configurations, and at the bottom it has a rank. Ultimately, the vessel that we do want to propose would be the vessel of size 36 feet. It has a twin diesel, aluminum hull, and half a cabin. And we found this result through the calculations we did in our Excel sheet by multiplying the weights with our scores and eventually adding all of those up to get a total score of 7.9989, which was the highest scoring vessel upon the 24 that we also calculated for. This is the vessel that we ultimately want to propose to the Texas Parks and Wildlife Organization.